This is pre-calc section 5.5 exponential and logarithm equations. We're only going to get the exponential equations done in this video. We'll do the log equations in another video. To solve log and exponential equations, we'll need the following properties. Now, the property we're going to use with our exponential equations is this one. The other two we end up using more with the logarithm equations. So this says solve each equation, give an exact answer. That means your answer will be in terms of log or natural log. When you have an exponential equation equal to a number here, the only way to get this x, which is an exponent, to be something solvable is to take the log of both sides. Perfectly legal. You take the log of both sides, and what we use here is this power property right here. This exponent gets to come down in front and become a coefficient, which makes it a whole lot more user-friendly. So this is log of 8/9 equals log of 2. Now, the reason I'm keeping the 8/9 as 8/9 and the 2 is 2 is because it's telling me to give an exact answer. We'll do a decimal approximation on a couple of these. Now, this is x times log of 8/9. If I want to get x alone, all I have to do is divide both sides by log of 8/9. And notice I haven't done anything with the calculator. And the other comment is, I chose to take the log of both sides. I could just as easily take the natural log of both sides, so MATLAB will accept both answers. This now gives us x equals log of 2 over log of 8/9. Now, a word about the calculator. To go and do a decimal approximation of this, you have to be very careful. When you press the word log, you get a front parenthesis come up on the calculator. When you type in 2, you must type in the back parenthesis there. And the same thing down here, log of 8 over 9 in parentheses, and that would give us the decimal approximation, which rounded to the hundredths place or to the thousandths place is negative 5.885. And these are very easily checked. Stow this as x, and then type in what you see right here, parentheses 8/9 to the x, and it comes out approximately 2. A little more complicated here because we have to get this exponential part isolated before we take the log or the natural log of both sides. So subtract 3 from both sides and divide by 7, and you should end up with e to the 3x equals 6/7. 9 minus 3 is 6, divided by 7 gives me the 6/7. Because this is e, I don't want to take the log of both sides, I want to take the natural log of both sides. Power rule is going to bring this 3x down in front. ln of 6/7. And the reason this is so nice is ln of e is just 1. That cancels out. So we just have 3x equals ln of 6/7. To get the x alone, divide both sides by 3, and that is your solution. ln of 6/7, but I'm putting it in parentheses to remind you that when you do your decimal that you have it in parentheses there, divided by 3. This one did not ask for a decimal approximation, so this is your exact answer. This is a lot more complicated because it is asking us for the exact answer first. So we did this in college algebra by doing a line of approximation. So here we're going to have to keep the ln or the log all the way through the problem. So the first thing is to undo these exponentials. We're going to take the log of both sides, which allows this exponent to come down in front and be a coefficient. Because it's a binomial, it needs to be in parentheses. And over on this side, the 2x comes in front, and now this is 2x log of 3. We need to distribute log of 5 through this parentheses. This is x times the log of 5 minus 7 times the log of 5 equals 2x log of 3. We've got to do some rearranging here. Remember what we're trying to do. We're trying to solve for x. Notice you have x on this side and you have x on this side. I've got to get x's together on the same side. So I'm keeping x log 5 on this side. I'm bringing this over by subtracting it from both sides. So I get negative 2x or minus 2x log of 3. At the same time, I'm taking the 7 log of 5 and sending it to the other side because it does not have a variable. Now, this is the situation where I have x written twice. I must get it written once to be able to solve, so I factor out x. So this is x times log of 5 minus 2 log of 3 equals 7 log of 5. This is x times this parentheses, so divide both sides by log of 5 minus 2 log of 3. It's a lot of writing. Log of 5 minus 2 log of 3. The left side, that cancels out. I finally get x all by itself. And this is my answer. This was a log of 3. So this is 7 log of 5 over log of 5 minus 2 log of 3. And that is the exact answer, keeping the log in there. You could have done the natural log, where this would be 7 ln of 5 over ln of 5 minus 2 ln of 3. Doesn't matter which one you use. What does matter right here are some parentheses. I know I need parentheses around that 5. You have two choices here. I would suggest you put big parentheses around the whole top. You're going to put parentheses around the 5, parentheses around the 3, big parentheses around the whole bottom. Your other choice would be to do 7 log of 5, hit enter, and there will be some sort of decimal showing on your screen, and then divided by, you do need the parentheses though around the bottom. And this is approximately negative 19.167. This is another one that requires a little bit more work. I need to isolate the exponential before I take the log of both sides. So subtract 2 from both sides and divide by 3. I have 3 to the x minus 3 equals 28. Take the log of both sides. The x minus 3 gets to come down in front and become a coefficient. So this is x minus 3 times the log of 3 equals log of 28. I want to get x alone, so let's divide both sides by log of 3. That cancels out. You might want to be safe right now and put those in parentheses so you don't forget. So now this says x minus 3 equals log of 28 over log of 3, or natural log if that's what you chose to do. Add 3 to both sides, so to save a little bit of room, I'm just going to put plus 3 right here, scribble this out, and that will be my answer for x. And the decimal approximation of that is about 6.033